Okay, this is the second example from your book. Motion of an object along a straight line. So they've given us a graph, and we have to kind of reason what the motion of this object is along a straight line. Now, this isn't the graph of the object. We'll zoom in a little so you can see it better. Because remember, we're talking about being along a straight line, so think of it like some object is moving across this line. And at some point, maybe it starts, goes to the right, then comes back to the left, and goes back to the right again. It's moving along some line, left and right. Okay. And specifically in this question, what they've told us is its position, which is this. S at t deals with the position on this line. Okay. Is to the right. So in other words, what they're saying is positive S at t is moving to the right. Okay, and that's important because that was denoted in the question. We know that it's talking about a horizontal line. So S at t when positive, S at t when positive is right, which means what would the negative be? Left. Okay. So when we're heading in a positive direction along S at t, we're heading to the right, and when we're heading in a negative direction, we're heading to the left. Okay? That's important for us. T is time. Okay? This is referring to the time, how long it takes us to get somewhere. So the question says, when is the object moving right? We already answered that. When is it moving left, and when is it at rest? So we have to find A to the right, B to the left, and C at rest. Okay? And we'll draw this horizontal movements in a moment. So we said when S at t is positive, or when we're going in a positive direction on S at t, that means we're moving to the right. Well, from 0 to 2, this is headed in a positive direction. Okay? So we know for a fact that we're going to the right between the numbers 0, when t is between 0 and 2. And also, it looks like, because they've put an arrow, so we assume it goes in that fashion for the rest of it, after 6 seconds, it heads in a positive direction. And because there's an arrow, we just assume it continues like that forever. Okay? So, in terms of A, it's heading to the right between 0 and 2, and okay, when t, or in time, is greater than 6 seconds. So between 0 and 2 seconds, and and after 6 seconds is heading to the right. So we'll go green for going to the right, we'll call it. Okay? So that's when it's going to the right. B asks us when it's going to the left. Well, when we're heading in a negative direction on S at t, it doesn't mean we're in negative S at t, it doesn't mean down here, because this refers to our starting point. It's just starting here on the line. So if we're on a horizontal line, think of this as the starting point, and it's headed out here. Okay? So it headed to the right. After 2 seconds to 6 seconds, it starts heading back to the left towards where it started. So it is heading to the left when t is between 2 and 6 seconds. Okay? So in other words, we'll put blue for the left. This means it's heading to the left. Okay? So we'll underline that in blue, or highlight in blue. That'll be better. So blue is left. Green is to the right. Okay. And finally, we have to find out when something's at rest. Well, at rest will be at a stopping point. Think about like all movement must stop. If we were to change directions, okay? If we were to change directions, we have to stop our movement and then go back the other way. So even though it might be for a minuscule second, we are at rest at that time. Okay? So we're looking when they change directions. Well, this thing changes directions twice here. Okay, we have changes of direction. We have a change of direction at 2, right here. And what we'll do is put another color. Do purple, okay? And we have a change of direction here. So those are, for C, when t is equal to 2 seconds and when t is equal to 6 seconds, we have changes in direction. T at 2 and t at 6. That is when this will be at rest. And at that point, think of it like slope of a tangent. Our slope is horizontal, which means our derivative is equal to what? Anyone know? 0. Okay? If the horizontal, our slope is 0. And remember, the first derivative of s at t, anyone remember what it stood for when we talked about it? Velocity. So that means our velocity at this point is also 0. So at these 2 points, our velocity is 0. We are going nowhere. We are at rest at those points. So let's try to get an idea. And I won't be able to do it exactly on the line. Actually, I can have a disappearing ink. How wonderful. So let's say we have our line here. Okay. This is our horizontal line. And this represents our s at t. This is where we started. Okay? And we're going to do this reference in terms of time. So it said we moved to the right between 2 and 0 seconds. So we moved to the right. And this time took us 2 seconds. Also, if you remember, this was position in terms of a starting point on a horizontal line. At that point, we are at 6. So we are 6 units. They didn't tell if it's centimeters, meters, miles, kilometers, who knows. We are 6 units to the right of where we started. So we've gone to the right. We are now 6 units away. And it took us 2 seconds to get here. Okay. Then from there, we're at rest. Now, it might be for a very minuscule amount of time. I'll eventually do this with a disappearing ink so you can see it all along, but I just want to get the idea all together. Then what happens? Well, we're at rest, and then we start heading to the left to our starting point again. Okay? So it looks like it never actually goes left of the starting point. So what happens is it now comes back to where we started. If you remember, at s at t, in terms of starting point, we're now 0 units away. We're exactly where we started. But this, in terms of time, has taken us 6 seconds to get here. Okay? And finally, it starts heading to the right again. Okay, so this one went to the left. And this one starts heading to the right again. And it looks like it's going to be infinite. It's going to go to the right forever. But because this is a horizontal line and I've kind of taken a detour, this would be the idea of this in terms of your starting point. So we're on a starting point. This object moves to the right, takes 2 seconds, turns around, comes back to where it starts. That takes another 4 seconds to get there, and then it heads off to the right forever. That's what they mean by s at t being on a straight line. This deviation I've made is just so you can see it in terms of the history of what has happened along this line. But technically, it's along a line. Think of it like Space Invaders. You guys ever seen that game, Space Invaders? Where you got that little plane at the bottom, and there's a whole bunch of aliens, and he moves just left and right. That's what we're talking about. It's on a left and right line, okay? It's not going up or down, and we're talking about its movements. So you start in the middle, maybe you move to the right, you shoot a whole bunch of aliens, and you come back a little because they're dropping bombs, and you go back over again. That's what this is about. Have you ever played Space Invaders, anyone? Good. Otherwise, that was a ridiculous reference. Okay? So it's on a straight line at all times.